If you are online, please calculate or write a formula that determines the length of a circular curve whose deflection angle is theta minus 2,5. Make sure it's radians. Okay. We are assuming that the angle you have is in degrees. Is that okay? All right. So please, I'll call someone to come and write it on the board. Do it for me. It's very easy. I'm just giving you the formula, and I've now given you values to put into the formula. Okay, so what is it? Oh, by now you should finish. Oh, it's the exam you suffer. This one, the exam is face to face. Don't forget, it's not online. Online people are getting 99, 95. And I was wondering, hey, what's going on? Okay. I'm waiting for you. What is the length of T1 to T2 if there's the angle subtended at the center? So I'll open bracket theta minus 2 phi1 close. That's it. If it's in degrees, then that would be wrong, isn't it? But then if it's in radians, then that'll be okay. So we assume that the angle is in degrees. So we multiply by, hey, face-to-face exam, please. I think. So on this face-to-face exams. Yes. What should we multiply by? If I give you 60 degrees to convert to radians, how do you do it? Pi on 180. Is that okay? Thank you. Please, we are all happy with what is on the board. We are moving on. We're taking an example. Oh, there's something I wanted to talk about, but anyway, let me just talk about it. Just right here. This is I, isn't it? Okay, so why are we interested in IT equal to IB bright plus BT? Why are we interested in this? Why are we interested in this relationship? Are we interested? Why should we be interested?
To get a length or distance.
To get a what?
Distance IT.
Get a distance IT. What is the significance of I? Usually, I told you for the first lecture that it's accessible. Is that okay? I is actually what begins the whole story. That's two lines. We start with something like this. I want to move from point A to point B. Are you okay? I. That's how we get the I. Okay. It's the first storyline. Are you okay when it comes to curve? Right? Whether it's circular curve or it's transitional curve. Are you okay? So I is the intersection point, and usually you have access to it, but sometimes you may not. In which case you have to find a way to solve the problem. All right, so that's it. Why do we have the B anyway? Why are we interested in introduce a point B here? Why are we interested in point B? What's the idea of the shift?
The shift is the difference between.
The shift is BP. But what is B? What's creating B? It's a shift. The introduction of the transition curve, isn't it? To join this, that creates that. Okay. So the actual circular curve that was here, we don't want it. We want to slowly go onto it. Are you okay? and reduce the effects so that comfortably we can get onto a circular curve. Are you okay? Can we get rid of the circular curve totally? Can we? These questions I'm asking, like I said, will turn into exam questions. So be active. It's okay. Be active. Can we get rid of the circular curve entirely? Why shouldn't we? Is it a possibility? Is it a possibility? And why? Engineers do the why. Technical people do the go and do it. Is that okay? Okay, I heard you do it. They do it and it blasts, it explodes. Is that okay? You are trained as an engineer, you should answer the whys. All right. So please, engineering students, reason about something. All right. So we can reduce the circular curve. Is all right. I'm not minding me. So you can literally reduce it and make it very small, or even let it disappear. But then you should know that you actually designed the transition curve based on the circular curve. So even though it's not there, you have an idea that this transition curve is for a circular curve of radius so and so. Are you okay? All right, let's move on. Okay, so you have three straights A, B, B, C, C, D, okay, with whole circle bearings 30 degrees. Is that okay? So AB 30 degrees will go like this. Okay. Why? Because 30 degrees, are you getting that? Or it could even be a bit shallow, but it's going to look something like this. So A will be here, B will be there. This is what the north, whole circle bearing. All right, BC is 90 degrees. So if this is the north, that means BC is lying flat like this. Yeah? Is that also? So then C. So it's like flat, okay? Just that I can't draw it. I can't draw it flat. Go something like that, okay? Then CD is 45 degrees. So CD is 45. That will go that way, okay? 45. Why is it 45? Because north is here. That is 45. Okay. So three straights A, B, B, C, C, D have whole circle bearings of 30 degrees, 90 degrees, 45 degrees. Is that okay? So this is the sketch C, D. AB is to be connected to CD by a continuous reverse curve formed of two circular curves of equal radius together with four transition curves. Okay. All right. So how do we go about it? So what he's saying is this: I want to come from a straight, okay, start off with a transition curve, okay, join with a circular curve, transition. Are you okay? So there'll be when you look at these two lines here, then there'll be a curve going in this way. So this one is circular, but there's a transition curve. Are you okay? It's another transition curve that joins this. Okay. Then there's a transition curve. Then there's a circular, there's a transition curve. So you end up with something looking like that. Okay. All right. And then you can also draw a line like so. All right. And then have this one like so. All right. So there's 45, that's 30, 90. Are you okay? 30, 90, 45. Okay. So we have a transition curve, a circular curve, transition curve, and that transition curve. Then we have a circular curve, we have a transition curve. All right. So when we want to design a curve, ideally you want a transition curve, especially if you're on like a long highway. You don't want to put in a circular curve at any point. Are you okay? And you wish you could just put in like transition. not even having any circular in it. Are you on the same page? All right. So basically, that's that. We've been given some parameters. It says BC, which has a length. So from B to C has a length of 800 meters. B to C, okay, 800 meters is to be the common tangent. So there's a common tangent, of course. Determine the radius of the circular curve. So question is to find the radius circular curve. Okay. The what again? So maximum speed V is actually 80 kilometers per hour. Okay. So the speed has to be in kilometers per hour, not meters per second, as I said earlier. Alpha, which is the rate of change of radial acceleration, is 0.3 meters per second cubed. All right. Give the offset and the deflection angle with respect to BC. Is okay to locate the intersection of the third transition curve. Okay. So one of the first things we can do is to calculate the length of the curve, because most of the formulas use the length of the curve, the transition curve. So V, remember the formula for V, or even the length, the formula for L. It's V cubed, isn't it? Over what? Hey, are you sleeping? Huh? Over what? Hey, are you sleeping? The place is hot, I know. What's the formula for L? Also, you don't know what it's called. This alpha. Okay. Alpha, beta, kappa, gamma, lambda, mu, etc. Are you okay? You need to know these Greek symbols. So VQ over R alpha. There's something is missing still, isn't it? Because what I have alpha is equal to V cubed over LR. Okay. Oh, it's the same, isn't it? Got it. If I make this one subject, take this one here. We know the speed. What else don't we know? Okay, so let's find V. V is equal to, oh, we know V already. Are you okay? We know V. We just want to find L. So we know V, R, we know alpha. Put it in. Okay, let's all calculate. Let's all calculate it. Put the values in. 80 times so blah blah blah. Work it out for me. It's going to be difficult, even though you see it very simple. Calculate the L. Not even the calculator. You see it's simple like that. Put in the speed and everything. You realize that it's not easy to calculate it. It takes some time, but I want you to do it very fast. Simple formula. Let's see how fast you're able to. I'm timing you. 11:39. Those online, they don't even know what we are doing, do they? Those online, are you following what we are doing? I think you already see it on the board, so you don't even have, you see that online.
Yes, we are following now.
Okay, I hear you. This is as hot as. Please hurry up. Anybody that gets it, try to do it, because if in exam I ask you to calculate this, to be too easy question to ask.
You have to change it to it's kilometers per. You have to change it to length.
So here we are calculating the length of the transition. How long should the transition curves be
To use this
based on the design speed, the radial, isn't it?
Yeah.
That's all. So you can see that it's even easy. It's easier than you even think.
Say the 800 is the radius.
The 800, this one.
Yeah.
This one is the length of B to C. Okay. Length of B to C.
The radius is
And what is
a
B and C? What are they?
B or
B and C, what are they? What is the engineering when you have a point like B and C? What are they? Exam question. What would you say?
a straight line.
They are the intersection of straight line, which is also known as the intersection. Thank you very much. Right.
So you said it.
He said,
Yeah.
no, but can't we see that?
Yeah, we know that it's a straight
We
line.
are fixing a curve to it.
But say when you said the engineering term, so
Oh, of course, it's
kind of
engineering.
confused.
Oh, really? So you think what we are doing is not engineering? Shit.
Oh no.
Okay, I'm waiting for you. Give me the value. Those online, don't look on the screen. Take a pen and paper and do it. Okay, so what do we really need to do? We need to convert, isn't it?
Yeah.
The units from kilometers to meters, isn't it? Like you have to be the same units. That's the challenge. Because alpha is in meters per second feet. So we need to make sure this 80 here is converted to what? Meters per second. Then this whole thing will now start working. So where's my marker? So 80 kilometers per hour. Okay, so you're going to get, we are cubing it, so 80 times what? 1,000, isn't it? 80. We need to keep all that. We divided by 1 hour is what? 60 minutes. That's another 60 minutes. All right, and then are we not keeping that as well? Yeah, keeping the whole thing, isn't it? All right, so this key indices is all right. So this we keep all right. Then we now can bring it in here, right? That's how you do it. But that's 1 hour. So 1 hour converted to seconds is 3,600. Exactly. And then you can now add all this stuff. All right, now when you look at the handout, they say an interesting way that it was done. I want to just write it down for you. The 3,000s you see there, 1,000 cube is 1,000 times 1,000 times 1,000. So this is the way it was done. I told you the British want to always complicate everything, didn't I? 1,000 times 1,000. No, but it's not a British, honestly. I'm just saying it. Divided by 45. 45 times 45 times 13.5 R. Okay, so here that's 45 times 0.3. Can you punch in a calculator? We don't know that. Are you okay? So someone is saying that this is R. You are looking for R, but we don't have it. Are you okay? The question is saying find the R. You've forgotten. Someone is saying that 800 is R. It can't be, because that's what we are looking for. So we don't have the value for R. Okay. What's 0.3 times 45? Oh, please, guys. Okay, great. So you see that, all right? Okay. So where from the 45? What do you think? Indices. Do you remember indices? If you keep something like this, what's going to happen? What's left of it? If you have this, that, and that, are you okay? We have R. Okay. Oh no, we are looking at that. We have R. Okay. So if R is here, all right, what give us the 45? Gotta be the rest of this. Is that okay? Okay. You don't get it. No, so now what I'm saying is that if you have this times that, and then you're able to bring out that, then 45 times 45 times that, it's actually coming from this, what is left of this. Is that okay? When you work it out, you get it. That's what I say. I don't think we should get into all the primary school calculation thing, but you will end up with a certain value. This is a convenient way to write it. Is that okay? Is that cubed? If you bring this out, you get 80 cubed, isn't it? Are we cubing that, isn't it? 3600. Okay.
Hello, sir.
Yes.
Please, I'm not getting the 45 by 45 by
You're not
13.5.
getting
I
it.
don't know.
Oh, it's just a
Yes, sir.
nice way of just canceling it out. Are you okay? If you try to convert 80 kilometers per hour to meters per second, are you okay? Then you need to multiply the 80 by 1000. Is that not so? To get a meters, is that not so? Are you there?
Yes, sir. Yes, sir.
Okay, okay. So if you actually cube the 1000, that's the 3000 you are seeing up there, isn't it? Are you on the same page?
Yes, sir. Yes, sir.
Okay, now the denominator will have 60 times 60 to convert the 1 hour to seconds. Is that also? Then what again? Then you have the 80 at the top, which hasn't been taken care of. Right? Okay, but let's assume that we decided to just compute all this, multiply it out. Are you get what I'm saying? What would be the challenge? Okay, if you try to do that. I mean, at the end, there's no help in the further calculation we are going to do. Okay, we want to write our answer in a certain form. Okay. Okay, so what is the answer? You're going to get 36580 meters over R. Guys, so punch, you can forget about the 45, just punch it and get this. I think it should be just fine. All right. This is just an easy way to do a calculation, like breaking it down. Yeah, what's up? Some calculators have formulas within it. Are you okay? And just one, but I think you need to just know what you are doing. You go into exam with calculators, but if you don't know how to use a calculator, how would you do it? It's all right. Did you get a 36,580? 79, which is 80. Are you getting that? What's maybe? Okay, so we have an expression for L. So L. Okay, so what is the shift? What's the formula for the shift? L cubed over 6 LR. Hey, you sure there? Okay, so what is, okay, so L squared over 6R, isn't it? Wow. Okay, let me just check this one. I hope I haven't given the wrong formula. Shift. Okay, the S is wrong. The S I give you is wrong. Is that okay? It's supposed to be L squared over 24. So check again. Let me see what you wrote down. Yeah. That's you shouldn't use this one. You should use that. Is that okay? Okay. That is incorrect. Okay, so that's if you use that formula for shifts. Then what is the shift per this question? So let's write it in terms of R. So shift it will become what would it be? It will make use of that, isn't it? Put it into this one. Square it. Are you okay?